Okay. Uh, Today we will discuss implementation of binary search using in my previous video we did it using recursive approach, but we write a C program which implements binary search, and it was implemented using recursion in C, language C. But now I will use a different approach, that is iteration based approach to implement binary search. In C language, to do iteration, so there are three features for doing iteration. One is called for loop, to while loop, or while loop. So I will show here while loop or and also the for loop. Using for loop, that means using iterative approach, using iteration, how can we implement binary search program. So here I am opening the file where we will write our C program. Okay, cd C program, cd searching. That means I am going to the folder where I will store my C program, and now this is cd bin search, that is a file name .c, not cd but gedit. So this will open the window where I can write the program. First of all, document and the implementation of binary search using iteration. So we will use a do while loop for this. So first of all, to write the C program, I am including stdio.h header file, and the number that we will a number will be given by the user, and this program will check the list whether that number which is given by the user is in the list or not. If it is found in list, then we have a successful search, and it will display the message that item has been found, and it will also indicate the location where the item is stored, in which location of the list. Actually, the list of numbers are stored in an array, and array index, the first element of array, is stored at location 0, and here I can take any size of array, but not a fixed size, but for that we are using a constant array size to find array size. And here for the program experiment purpose, we are taking the array of size 10. That means 10 numbers will be there, so the value of the constant array size is 10 here. Now I will write the main program, which is now obviously this main function, it will, after execution the full program, the return 0 is written at the end of. so that main will return integer 0. That is the format for C program that will be compiled by GCC compiler, which is built in Ubuntu. Okay, now I have to give the array element, so I will declare an array and I will indicate all of its element. So 1, 5, 10 elements to be there, and one of main point is that in binary search the array should be in sorted order, maybe ascending or descending. So we are using a sorted array, sorted in ascending order. Okay, 10, 15, 20, 25, 30, 35, 40, how many? 2, 3, 4, 5, 6, 7, 8. The last element, 44. These are the elements which are stored in array. Okay. Now, so the first element is stored in 0th element is 1, and the last element index is 9. So for this list, what is the lower value, lower index, and what is the higher index? So a variable will be declared for storing the lower index and storing the upper index. So I am declaring a variable lower, and we are assigning the value 0 to it, because initially the list which will be searched, that index is lower index is 0 and upper index will be 10 minus 1, that means array size minus 1, and the input will be stored in variable num, that means which number you want to search in the list, that is to be stored in the variable num. So here is a printf which is giving instruction to the user to enter the value for num. So enter number to be searched, and this number should be entered into the program using scanf %t and ampersand num. Now we will not search the every element in the list in binary search program. First we will check whether num is matched with the element which is center of the list, because as it is sorted array, if it matches with the mid element, then okay, you have found the number in the list in that mid location. But if that element is less than the middle element, that means we can divide the whole list into two halves, lower half and upper half. All the elements of the lower half, the values of all the elements of lower half are less than the middle element, and all of the values of upper half have values which is greater than middle element. So if array does not match with the middle element, next, so what I am doing here, checking whether this we have to calculate the value of mid here. So another variable I need to declare, which is mid, and mid equals to lower plus upper by 2. Now it will be, the number will be compared with the middle element of the list. So if it matches, that means if num equals to array middle element of the array, then middle element of the array. So in that case I will the number the how many times the comparisons has been made. Now one times. First, in first comparison it matches, so we can indicate how many number of comparisons have been found to get the answer, whether it is a successful search or it is an unsuccessful search. So I will declare a variable which is int number of comparisons will be initialized to 0, and after this comparison we will increment the value of variable number of comparisons by 1. So number of comparisons plus plus, and next you show a proper message printf that percentage d, that means a number is present is found at percentage d location after percentage d comparisons. So this is the num is found at location meet, and after number of this many number of comparisons. Okay, actually this is one condition. If this condition is not satisfied, then what other conditions may be possible? If the num is less than the middle element, that means the num all of the elements which is left side of the middle element, their all values of those elements are less than the middle element, and the elements which are right side of the middle element, all the elements have higher value than the middle element. So the condition is, another condition is else if array in num is less than array mid. In that case we have to search only the lower half, not the upper half. So this is also one comparison. So number of comparisons, this value will be incremented by 1, and we have to search the lower half. The total list middle element is there, and we have which divides the list into two halves, lower and upper. Lower half means it is left side of the middle element, upper half means it is right side of the upper element. So when num becomes array of mids, and we have to search the lower half. So only the lower half, the upper value will be modified. And what will be the upper value? It will be mid minus 1. Only this modification to return. But the another possibility of condition is else if num is greater than array mid, then that means we have to search only upper half. So, and also there is one comparison for this condition, number of comparisons number of comparisons are incremented by 1, and as we will search to upper half, so I have to modify the lower index value of this the portion of the list which will be searched next. So lower value will be equals to mid plus 1. Okay, So now again I have to check that whether none is now with now again middle value need to be calculated. Middle value need to be calculated. New mm, hmm. So the new middle value will be as the after this, as the lower and upper values changed. So that's why middle we have to calculate the middle value for the new list, for the new portion of the list. So mid value will be updated here, which will be lower plus upper divided by 2. Okay, and again I have to compare the number with this new middle element, which belongs to either first half of the previous list or belongs to the um, upper half of the original list. Okay, so we can implement iteration by using a while loop, and when a while loop, and what will be the condition that loop will be executed. As long as lower and up is less equals than upper value, that loops will be continued. But how this condition, how we were getting this condition, that I will show theoretically in the next video. So here the condition is, if lower becomes the greater the upper value, that means the search is unsuccessful. So in that case you have to the loop will not be continued. So continuation of loop only happens till that time either you have found lower is less equals than upper. Okay, now you are coming out from this while loop, do while loop. Now within this do loop there is one thing, either it can be a successful search, and after that if it is finds the matches with the middle element, then I have to come out from the loop. That is, after successful search I have to use break option to be come out from the while loop. Now when it is coming out of the while loop due to reason unsuccessful search or due to maybe successful search, but how can we differentiate this? So for that we are introducing a flag variable which is initialized to 0. If it is a successful search, then we are changing the flag value to 1. But if it is unsuccessful search, then the flag value will not be modified. So when after the while loop it will check the flag value. If flag equals to 0, that means it is an unsuccessful search, and printf the proper message that %d is not found in the list after %d comparisons. So which is the number and number of comparisons. So this is the program. Now I will save it. I will save this, and now I will compile this program. GCC bin search .c. I'm just compiling the program. Now I will run the program. Enter number to be searched. Suppose it is 1. See, 1 is found at 0 location after 3 comparisons. So it is showing 3 comparisons. How it comes 3? Because if I open the program, you see the lower value is 0 and upper value is 9. So middle element will be 4, fourth location, which is 0, 1, 2, 3, 4, 20. So it will compare will be 20. So first comparison, that is number of comparisons now is 1, but the number is less than 20, so it belongs to the lower half. So the upper will be in this new portion, the upper value will be mid minus 1, which is 3. Now lower value is 0 and upper value is 3. So middle will be 1. So next middle element will be 5. So it will compare with 5. Again the array is number is less than the middle element, so it will belong to the lower half. So in this lower half, the new upper value would be mid minus 1, that means 1 minus 1, 0. Now lower and upper both are 0, so mid is also 0, and this time the number matches with this new middle element, and it is a successful search, and so the number of comparisons will be 3. So first comparison is done with 20, next comparison is done with 5, and the last comparison is done with 1, which matches. So total 3 comparisons. So okay, I am giving another search. Suppose 50 is not found in the location. I will just a minute. I will the word I have written here in the list. I have written lost. Okay. So I will once again compile the program. Okay. Now again I will enter 50. 50 is not found in the list after 4 comparisons. How 4 comparisons comes out, that I will show. If I go to the program, first it will be compared with 20, and it is 50 is greater than, so it will search the upper half. So lower value will be mid plus 1 means 5. So 5 is lower and 9 is upper. So 7th element, it will be now comparison will be done with 7th element in the apex. 0, 1, 2, 3, 4, 5, 6, 7, that is it will be compared with 35. Again the 50 is greater than 35, so we will go for upper half. So lower value will be modified, which will be mid plus 1, that means 7 plus 1, 8. So lower value is 40 and upper value is 45. So 8 plus 9, 17 divided by 2, so 8. So comparison will be done with 40. Again it is not matches, so and the element is greater than 40, so we will go to upper half. So lower value will be now 9, upper is also 9, and mid element is 9, which does not match because 9th element 45 and 50 does not match with it. And after that, as it is array lower is both array the number is greater than the middle element, that is greater than 45, so I will increment the lower value, and in that case lower becomes greater than the upper. So that means it is unsuccessful search, and so first, now how many number of comparisons have been done to get the answer. First there is comparison with 20, then it becomes 5 plus 9 means 7th element. 0, 1, 2, 3, 4, 5, 6, 35 comparisons has been done. That is 2 comparisons. Then it is compared with 40. Next it is compared with 45. That is Total 45 comparisons have been made, and it is unsuccessful search. Since item is not present in the list. Okay. So